Okay, in this video, we will continue our discussion about the origin of the solar system. So in the last video, we have asserted that the dust particles that are in the protoplanetary disk clump together and form planetesimals. The planetesimals form protoplanets, and which eventually became planets. Now, that begs the question, why would the star that is formed at the center be spherical? And why would the planets also surrounding it be spherical when it could have been flat, right? Like how the flat earthers would tell us. But I'll give you a proof, and again, this proof is using a computer simulation. And again, computer simulations, do not underestimate computer simulations. Yes, they're not real, but they emulate reality. In fact, a lot of the designs of ships, of how cell phones work, a lot of the blueprints of all the technology that we have, most of the time are modeled in computer software before they're built, and they work. The fact that they work, that means we should trust that they can also emulate what's happening before about things that we cannot observe, like for example what happened before. So we can use computer simulation. So I will show you here a computer simulation. This is a computer simulation. So what the programmer is doing here is putting in a lot of particles, and each those particles have the same mass, and he just simply inputs the equations of gravity, like how a particle is attracted by other particles when you put them in space. So, and in this case, he is using dice. And if you notice, no matter how randomly they distribute it, what happens is the particles, because of gravity, will always clump together. So you see, the particles are now starting to clump together. So, and then the particles that are bigger also clump into even bigger particles. See? And guess what you form? You will always and always form a spherical configuration. You will never form a flat form as long as it's one object. Obviously, the structure of the solar system is flat because that's not one object. But when you're talking about one object, one solid object, you'll always form a sphere like that. Okay? Because and again, this simulation is not like core not I mean the behavior of the dice here is not like it's dictated by the creator. What the creator does here is just simply put in a bunch of particles, put in the equations of gravity, and let it behave the way it wants according to how gravity would do it. And guess what? It forms a spherical configuration. And again, you have to understand that that makes sense because again, say for example, you have a blob of materials here and a blob of materials here. This is big, right? So what happens is they will attract each other, and if they will attract each other, they will collide, and they will join and form one structure. And what happens is, you know, just like in Earth, right? In Earth, if you have an object here, there's gravity, right? If you have an object, right? If you have or let's make it like this. If you have a like a pole, long pole, and if you have a longer pole, what happens is that longer pole, because it's heavy, its tendency is to fall over towards the ground, right? If you have a shorter pole, it's not that heavy, so it's my point is, if you have a shorter pole, a longer pole, even without the concept of wind or other factors, this would probably fall down more often than not compared to the shorter pole, just because it's so far away from the center of the Earth. Okay, and so gravity builds up. It's not that gravity becomes stronger, but the weight of this plus its location. Remember, we have a concept of, again, you have to remember all the other concepts. You have the concept of gravitational potential energy. So if you have an object here, which is, you know, far from the ground, compared to an object here, that is so high that if you calculate the gravitational potential energy, which is mass times acceleration due to gravity times height, that height makes it that the gravitational potential energy is so big. So therefore, just because it has a lot of energy, it would tend to fall down if it's at a higher elevation. So what am I trying to say? What I'm trying to say is, let's say you have an object like this, and then another object is like this, and it gets attracted to that second object, and it sticks like that. Guess what? That object is high compared to the surface, that it would tend to fall down. So over time, it will flatten out and join, and again make a sphere, and not like a big blob that is kind of sticking out from the surface, right? So I hope I am making sense, but that's a proof that you can never have flat Earth. Okay, so shout out to all the flat earthers out there. Nope, the Earth is not flat. The Earth is spherical or oblate spheroid, just like all the other planets, just like all the other stars, just like black holes and other things. Okay, so that's the idea. So again, let us go back to the theory. So now that we have protoplanets, it was estimated that there were 20 to 100 protoplanets that were formed in the early solar system, and because there were 20 and to 100, they were in a crowded they are in crowded orbit, so it's very crowded. And obviously all of these dust particles, some of them were left over. Okay, so remember, dust particles created planetesimals, planetesimals became protoplanets, protoplanets became planets, but some of the planetesimals did not evolve to become protoplanets. Some planetesimals were just simply left over. And these leftover planetesimals did not form protoplanets, and they became what we now call asteroids, comets, dwarf planets, and Kuiper belt objects, or even Oort cloud objects. Okay, so the analogy here is kind of like, if there is a carpenter, and that carpenter is making uh making a chair, obviously he would not be able to use all of the wood. There will be some leftovers, maybe some shavings that are left behind, and that's the idea. So the leftover planetesimals became this. Okay, the asteroids, comets, dwarf planets, and Kuiper belt objects. And again, let's go back to what we know about the structure of the Earth. We know that the structure of the Earth is, the lithosphere, asthenosphere, but at the center there is this core of iron and nickel, right? There's this core of iron and nickel. And do you know why we know that there's iron and nickel there? Well, we know because number one, the Earth has a magnetism. There's a magnetic field of the Earth. And the only things that can create magnetic fields are iron, nickel, and cobalt. But why do we know that there's not a lot of cobalt but a lot of iron and nickel? That's because of, again, the analogy of the carpenter. Say, for example, you go into a carpentry shop, and then when you went into the carpentry shop, you have these shavings of mahogany wood. Right? You have these shavings of mahogany wood on the floor. And then the carpenter is saying, you know what? I made a chair. And then the carpenter would say, guess what wood did I use? What would you answer? Simple, right? You say it's mahogany. Because we see the leftovers. And the leftovers are mahogany. So it's the same thing with the Earth. Obviously, we knew about the crust because we can access the crust. We knew about the mantle because the mantle materials can sometimes come out because of volcanoes. But how did we know that it's really nickel and iron in the center? Well, it's just like the carpenter. We look at the leftovers, and in the leftovers, we see a lot of mahogany wood, and therefore we can conclude that the chair is made up of mahogany wood. So in this case, when we looked at the asteroids, comets, and other things that are considered leftover planetesimals, they contain a lot of iron and nickel. Okay, let me repeat that. When we investigated asteroids, comets, and obviously sometimes asteroids and comets get to the Earth, you have meteorites and crash sites like that. when we looked at their composition, what we always see is there's a lot of iron and nickel. And when we compare that to the percentage of iron and nickel in the surface of the Earth, because that's the only thing that we can see. Obviously, there's also iron and nickel on the surface of the Earth. That's why we have buildings. That's why we can make iron steel bars that support our buildings, because there's iron. But if you look at the percentage of the amount of iron in the crust and even in the mantle, it's very, very far away from the percentage of iron that we find in the leftover planetesimals. Okay, so again, the idea is it would be impossible that the leftover planetesimals would contain a lot of iron, and yet our Earth is an exception. We don't have a lot of iron. It's kind of like, again, finding out that there's the shavings of mahogany wood in the carpentry shop, and yet the carpenter was making a chair not made up of mahogany wood. It's kind of like impossible, right? So scientists figured out that the amount of the percentage of iron and nickel in these planetesimals should be the same as the amount of percentage of iron and nickel in the Earth. But we cannot find it on the surface, on the crust, on the lithosphere, so they must go somewhere. And considering that these are heavier materials compared to the silicates, so therefore they concluded that, because of gravity, they would probably be heavier, so they would probably be affected by gravity more, so they would probably drift towards the center of the Earth, so we would probably find them in the center of the Earth. So that's why we have a theory that they are found in the Earth. And in fact, that also supports the idea of the magnetic field, because the idea of a magnetic field kind of surrounding the Earth tells you that you should have an iron core at the center. Okay, for those of you, obviously, why would it be at the center? You would not probably understand that. But for those of you who have experienced this experiment, this is a common experiment in in elementary and even in high school, where you have an iron nail, and then you have wires, and then you kind of wrap the wire around the iron nail, and then you supply a battery. What happens to that? When you supply the battery, all of a sudden, whoa, this iron nail becomes a magnet. And that's because you have an iron nail at the center. So in the Earth, it's kind of like the same. The center core, namely the inner core, is kind of like this iron nail. And then the outer core, which is liquid, because it's liquid, the outer core is kind of rotating. So it's kind of like the equivalent to the electrons that are rotating in the wire. So you see, this battery pushes the electrons to flow around the iron. So it's kind of like this, where the inner core is like the iron nail, and the outer core is like the rotating electrons causing magnetism in the Earth. So that's the idea. So again, we have a lot of these evidence that seem to be not connected but are really connected. So again, if we can do that and make a magnet, so we can do this also and make the Earth a magnet. Obviously, there are holes in that analogy. There are certain things that are not the same, but you get the idea, right? And then another thing is also, again, scientists have a concept of what we call angular momentum. So if you have a sphere that is hollow, and you have a sphere that is not hollow but solid, even if they are the same size, even if you make it such that they have the same size, when you spin it, because of angular momentum, the shallow would spin differently from a solid one. Okay? From a solid one. And therefore, the idea is, just by looking at the spin, you can actually find out the mass of the Earth. You can find out if the Earth has a hollow center or not. So, shout out to all of those people who believe in the hollow Earth theory. We know that it's not possible, because if the Earth was shallow, it would not rotate in the same speed that it's rotating right now. So we know it's not hollow. And in fact, we know that the Earth should not have the same material as the crust, because if the Earth would have the same material as the crust all throughout to the center, then the Earth would be too light to create our rotation. The fact that our rotation is at that speed that we have right now, it's implied that the center must be heavier than the rest. So that's why we know that the center of the Earth is iron and nickel. Okay. So again, I know our main topic is about the discussion of the origins of the solar system, but I really can't help it. Again, for me, science should be studied by looking at connections. So that's why I'm connecting it to how we know that the center of the Earth is iron and nickel. And again, I enjoy science not because of the concept that it brings, but just how interconnected the concepts are. And I hope that you would also appreciate that, because again, it's not science when you just memorize things, right? And then here, number 10, the interactions. Let me transfer myself up top. The interaction of the protoplanets caused some collisions, destruction, and shifts in orbits of planets, and until only 8 major planets are left. So here, obviously, because they are in crowded orbits, it is inevitable that these orbits sometimes get entangled to each other, some collide, some of those things happen. And why do we believe that they collide? Well, because we have a lot of evidence. Number 1, for example, number 11, collisions of protoplanets cause the tilt of rotations of Earth and Uranus, or Uranus. You see, when the blob of particles rotated like this, for example, so the rotation is like this, guess what? When a planet is formed, its rotation should also be like that. It can never be countered, because if the rotation of the blob of particles is like this, then all of the planets will rotate in the same direction, and in fact, each planet will have the same rotation also internally. All of the planets revolve in that direction, and all of the planets will also rotate in the same direction. So let me get that straight. If the planets is rotating like this in this direction, internally it should be rotating like this, the same direction. But guess what? The only exception is Uranus and Earth, because the Earth, instead of rotating like this, you know that the Earth is tilted 23 degrees, more or less. So scientists are saying that the fact that the Earth is tilted like this, it's a proof that sometime there was a collision that hit the Earth and kind of knocked the Earth to 23 degrees to its side. That's why it's now rotating 23 degrees. And in fact, for Uranus, it's even worse, because it's even more dramatic, because Uranus is not now rotating like this, it's rotating like that. So I know it's not represented because it's not a sphere, but instead of rotating like this, it's rolling on its side like a barrel. And again, we feel, and scientists say that you can never, with our models of the blob flattening out because of rotation, we can never get that tilt, that sideways rotation of Uranus, if not because of collisions. So we feel that some things have collided. Okay, and in fact, if you look at entry number 12, collision between the young Earth and a protoplanet called Theia caused the formation of the moon. Okay, the protoplanet Theia caused the formation of the moon. We believe this because if you look at the materials in the moon and the materials in some of the mantle of the Earth, they are similar yet different. You know what we are, you know, it's like it has some components that are the same, but it has some components that are different. And in fact, they can identify 2 sources from the Earth and 2 sources from the moon. So that's why we now believe that there was this planet, the young Earth, and then another planet called Theia, and then they collided. What happened was Theia kind of obliterated a part of the Earth, and it shut up on the above the Earth, and also Theia itself was obliterated, and then the leftover became again a cloud of dust particles. And just like how the dust around the planet, around the sun, kind of conglomerated to form planets, that dust particle from the collision of Earth and Theia conglomerated and formed the moon. And in fact, we know that because some of the materials in the Earth are similar to the moon, and some of the materials of the moon are similar to parts of the Earth, but not all parts of the Earth, but in some sections of the Earth. So so that means that we kind of know that there is at least a reasonable pile of evidence to say that this collision could have happened. Okay, obviously there are other theories, and again, we are not sure about this stuff. But again, appreciate the thought put into. I mean, it's not like some scientists just said, okay, there was this collision created the moon, and then okay, I don't present any evidence. But there are evidences like the materials of the moon being similar to some of the materials of the mantle of the Earth, and there are some mixing of materials in the moon and the Earth, things like that. Okay, and then finally, we believe that the shift of orbits of the giant planets in the solar system caused most of the planetesimals to be thrown into inclined orbits in every direction. That did not follow the plane of the major planets. So there's this shift of the gas giant planets. So number one, why do we believe that there's this shift? What do you mean by a shift, sir? What we mean by that is, this is the sun, this is Mercury, Venus, Earth, Mars, and Jupiter. We believe now that Jupiter was not there. It's not in its place right now. We believe that Jupiter was way further out, and then it simply drifted inwards. Okay, we believe that Neptune might have also done, not Neptune, Jupiter. Yeah, Neptune might have done the same also, and Uranus, they might have shifted some of the orbits. Maybe they exchanged. Maybe Jupiter was here, and then they kind of exchanged order. And why do we believe that that is the case? Why do we believe that there was the shift of the giant planets? Okay, because again, we can see that in simulations. Okay, the first thing here was we noticed that a lot of the craters in the Earth, and the craters in the Moon, and the craters in Mars, and craters in Venus, and things that we can see, have the same age. Okay, so craters that are coming from meteorites, right, and then other falling things from comets, they have the same age. So if they have the same age, they must have, meaning there was a time in the solar system where a lot of comets simply bombarded the inner planets. So we call this the early bombardment era and the late bombardment era, where a lot of planets just simply shifted. A lot of comets simply kind of fired upon the planets, Earth, Mars, Venus, the Moon. Obviously, the Moon is not a planet, but you get what I mean. And they can roughly estimate that they happen kind of the same era. Okay, and so if that's the case, then meaning there must be something major that happened during that time. Otherwise, why would be a lot of comets be bombarding onto the inner terrestrial planets? So they they put that in a model, right? They put that in the model, and this is what we see. Okay, by the way, this is again a video I took from YouTube, and again, this is even a scientific research. This is not like a video created just by some YouTuber, but this is really backed up by scientific data. But this is the idea. This is the solar system, right? And if you look at the solar system, and that's the rotation of the planetesimals or protoplanets at that time. And if you notice, it's fairly irregular, fairly irregular, but then something happened. See, there's a shift of the object, shift of orbits. And you notice what happens immediately when there's a shift in the orbits? See, when the orbits become kind of chaotic, See, a lot of smaller planetesimals and even some protoplanets were thrown out. Some of them were thrown out, some of them were thrown in. Because remember, you have to understand that the rotation is a balance of all the gravity of all the planets. So if the planets kind of shift, especially planets that are big like Jupiter, they kind of affect how the other smaller things rotate. So when the planets shifted orbits, especially the bigger ones, Jupiter and Neptune, they threw out a lot of the planets outwards, but at the same time they also were able to throw some of them inwards towards Earth, towards Venus, towards Mercury, towards the moon if the moon was there. So therefore, that is what happened. So when the shift happened, some of the planetesimals were thrown out into inclined orbits, and that created the Kuiper belt. Some even were thrown out so far away that it created the Oort cloud. Okay, so again, that's why I said it's important for us to understand the structure of the Kuiper belt and the Oort cloud, because the Oort cloud and the Kuiper belt is tied into the narrative of how the solar system was created. So again, let me repeat, this is a simulation, meaning this is not directed in any way. We just input data and then we kind of let the computer run and see what the particles do. So again, fairly stable, but when a kind of orbit wobbles, you see some instability, and then when there's a lot of shifting, a lot of planetesimals get thrown out and also thrown in towards the inner solar system, right? And that is what happened. And in fact, there's a theory that if Jupiter did not shift inwards, the Earth would have been not habitable, because the position of Jupiter right now is very ideal, because it's not near enough to gobble up the Earth, but not far enough to not protect the Earth. What that means is, if there's a stray asteroid from somewhere else, even if it wants to go to the Earth, because Jupiter is so near, it will actually shield the Earth from those asteroids. Okay? And that's how we get the solar system that we have now. So again, one thing to understand here is that these are simulations. Simulations are created by computer programs, and they are not in any way controlled by the creator or anything. We just input the formulas, and then we let it rip, and that is what happens. So again, we might not know like the details, like the individual details, like when or how, but we know that some sort of shifting happens, and that shifting caused the early bombardment, the late bombardment, and in fact, some again even theorize that the Earth did not get water before this bombardment era, because when you have comets bombarding the Earth, a lot of these comets contain water. Okay, a lot of these comets contain water, and it's the accumulation of those. We believe that some of these comets brought water to the Earth, and that's why we have a lot of oceans. So because you have to understand another theory is this. Remember the protoplanetary disk? You have a protoplanetary disk, right? And then this becomes very hot, very, 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 very hot, until it ignited. When it ignited, it started the fusion. But when it ignited, it's just like an explosion, right? So meaning when there's an explosion, it kind of pushed materials away. Okay? And why do we believe that this explosion happened? I mean, not really explosion, but again, it's like an explosion in the sense that it creates some shockwave when this ignited. Why do we believe that this happens? Because it's logical. I mean, think about it. If something explodes or something throws objects away, if I have a heavy object and I compare it to a lighter object, if I throw them, what's the pattern? Right? Logically. The pattern is heavy objects are heavy, so therefore you could not throw them far. So what happens is when this exploded, all of the heavy materials stayed relatively close. So let's color code. The heavy materials are the red ones. Stayed relatively close because, you know, no matter how strong the shock wave is, because these are heavy, they could not be thrown further out, right? And then obviously the lighter materials, let's color code it with green. The lighter materials were thrown out. Okay? And in fact, that is good because it supports what we observe. What do we observe? Mercury is a rocky planet. Venus is a rocky planet. Earth is a rocky planet. Mars is a rocky planet. And what are not rocky planets? The gas giants, Jupiter, and did I miss something? Jupiter and what was the other one? Jupiter and well, Jupiter, Neptune, and then the icy planets Uranus and Neptune. Oh yes, Saturn. Sorry, forgot about Saturn. I'm sorry. Mercury, Venus, Earth, Mars are rocky planets, and then Jupiter and Saturn are gas giants, and then Uranus and Neptune are icy planets. So you see, why are they rocky? Because they are made up of materials that are heavy. So you see, it's not that scientists are making this up. The narrative makes sense. When that star ignited, it threw materials away. But when it threw materials away, obviously it could not throw materials that are heavy far enough, so they will conglomerate closer. Then the lighter materials will be farther away. So that's why the first inner planets, are made up of rocky things. They're heavy, they're made up of metals. But Jupiter and Saturn are gas giants. And Uranus and Neptune are icy giants. Icy planets. So water class, even if it's not an element, but it's a compound, water is relatively light. So if it's relatively light, when this exploded, water, some scientists argue that water would have not been in Earth. Would have been thrown outside and probably carried by comets. And therefore, again, when the planet shifted and caused all of these planets to be bombarded inwards, hitting Earth, hitting Mars, hitting Venus, some scientists believe that it's the comets that brought water to the Earth. Okay? Obviously, are we sure? We are never sure about anything in science, but isn't it amazing how the narrative simply lines up? Okay? How the narrative makes sense. We might not be sure, but the fact that there's a logical kind of flow in the narrative, it makes us more confident that this must have been what happened in the creation of the solar system. Okay? So now we can explain how the Kuiper belt and the Oort cloud were created, because here objects thrown very far away from the solar system form a spherical collection of icy bodies that we now call the Oort cloud. Okay, and again, we have listed here all of the evidences for why we believe that these are true, but most of them I've already discussed. But in case you're interested, I will also post this on our learning management system. So again, this is how the solar system is created. We started from a cloud of nebula, started rotating because of supernova. The rotation caused it to flatten out. Most materials condense at the center. And when you compress something, it would trigger fusion, as is proved by tokamaks that we can build in Earth. And then that fusion threw particles away, causing this distribution where heavier particles are at the center, closer, and then the lighter particles are farther away. And then because of the further rotation, they create static electricity, which caused them to clump together into dust bunnies, and these grew and grew to become planetesimals. The planetesimals grew and become protoplanets, and by that time we have now 20 to 100 protoplanets. Some of the planetesimals did not really become protoplanets, and they become leftovers that we are now calling the asteroids, the comets, and the dwarf planets. And then, but some of these planetesimals collided with each other. It was very chaotic. The orbits were crowded, such that it caused some migration of planets. Most dramatically, the bigger planets, Jupiter and Saturn. I was mentioning Neptune, but I really meant Jupiter and Saturn because these are the biggest planets. Caused some of the leftover materials to be bombarded inwards or bombarded outwards. The bombardment inwards is now proven to have caused the craters in the Earth, in Mars, in Venus, and so on. And then the bombardment outwards, I mean the cost of materials moving outwards caused the formation of the elliptical inclined orbit called the Kuiper belt and the sphere that we now call the Oort cloud. So that's how the solar system was created. Obviously, there's still a question like, okay, we have a nebula, a dust of interstellar dust that created the solar system, but where did that dust of where did the interstellar dust or the nebula come from? We have to discuss the origin of the universe for that. But as of this video, that completes how we believe the solar system was created, what its origins are. But again, you must understand that year by year we learn more. So some of these things might be changed, but again, that's not the point. The point is we can explain it. We have levels of degree of confidence to believing to believing the narrative of how the solar system was created. But again, some of these things might change, and again, in science we can never be 100% sure about anything. But again, it's very interesting, it's very enjoyable just to see the narrative play out, just to look at all of these evidence kind of tell you a relatively coherent story. It's not detailed by any means, it's not complete, but at least it's believable. We have a high degree of confidence that this might have been what happened because of the evidence that we can see. Okay, that's the origin of the solar system.